Okay, now in this numerical they say an iron ball of mass 100 gram strikes a wall at an angle of 30 degree with velocity 10 meter per second and is reflected back at same angle with the same speed. If the ball remains in contact with wall for 0.1 second, then find the force experienced by the wall. Now let us draw a rough sketch for this one. So here we are showing a horizontal line. This is representing a wall, right? Now on this wall they are saying a ball is striking. So let this be the movement of the ball, and it is striking at an angle of 30 degree with the wall. Now here mass and velocity of the ball is known to us. So first of all we can get the momentum in the ball, mass into velocity. So mass of the ball is given 100 grams. So we will convert it into kg, and then velocity is 10. So we will be getting momentum as 1 kg meter per second. This is the momentum. Okay, here P. Now as the ball is moving, making an angle of 30 degree, so what we will do here, we will resolve this momentum in horizontal and the vertical component. So we will take the horizontal and the vertical component of it. So this angle will be of 30 degree. So this will be the horizontal component, so that will be P cos 30 degree, and this will be the vertical one, so this will be P sin 30 degree. This is also 30 degree. Now ball strikes the wall and then it is reflected back at the same angle. It means here it is making the same angle of 30 degree and returning back with the same speed. So momentum remains the same. Now here when it's returning, then again we will resolve it into two parts, the horizontal one. So let this one be the horizontal and this green one showing the vertical. Now here this angle will be of 30 degree. So horizontal component will be P cos 30 degree and the vertical one will be P sin 30 degree. Okay, now if you see in the diagram, then you will be finding that these two horizontal components, while ball traveling towards the wall and the other when the ball is traveling away from the wall, these two horizontal components, they are in the same direction. So if I ask you to find the change in momentum in the horizontal direction, so change in momentum in horizontal direction, so that will be P cos theta, P cos 30 degree minus P cos, we will subtract these two, and so change in momentum will be 0. So there is no change in momentum in the horizontal. Okay, now for change in momentum, in vertical direction, in vertical direction. Now you can see that these two vertical components are in opposite direction. So if we find their change in momentum, so what we will do, these are in opposite direction, so one will be positive, the other one will be negative. So change in momentum will be p sine 30 minus p sine 30. So this will give you p sine 30 and then plus p sine 30. So your result will be twice p sine 30. Now substituting the values in this one, so it's twice into p, value of p is 1, and then sine 30 is half, so you are getting it as 1 kg meter per second. So this you have got change in momentum in the vertical direction. So you can see there was no change in the horizontal direction because both were in same direction. So if you subtract them, result will be 0. But about the vertical, they are in opposite direction. So one will be positive, other one will be negative. So when you subtract them, you are getting twice. So this is the total change in momentum, no change in horizontal, and this is the change in vertical. Now the question says you have to calculate the force you have to calculate. So you can write force is equal to change in momentum upon time. So change in momentum we have got 1, and as you can see in the question, time given was 0.1 second. So it is 0.1. So when you simplify it, you are getting it as 10 Newton.